Hi everyone, this is Mr. Bozaday, and I am going to work through the first question on the what is power worksheet. And so here we go. So the question says that a 60 kilogram box is lifted by a rope a distance of 10 meters straight up at a constant speed. How much power is required to complete this task in 5 seconds? So let's first start by refreshing ourselves on what we know about power. The equation for power is that power is the change in energy over time, the transfer or the transformation, that is, of energy over time. But it's the change in energy over time. The units of energy are joules per second, or we know that we've got a special unit for that, which is watts, which is why this worksheet's called What is Power. And the definition of energy is power is the rate that energy is being transferred into or out of the system or transformed within a system. So it's a rate. Power is a rate. It's the amount of joules that are being transferred or transformed every second. And we measure that in watts. So now let's jump into this problem. Whenever we've got an energy problem, I always recommend that you quickly sketch out your LOL diagram, which means we've got to start by setting our system. In this case, I am going to try and put all of my energy in the system so that we can kind of practice the transformation scenario for power. So I'm going to put the box, the earth, and the rope all in my system. And the idea is that well, I guess I should say the next thing that's good to do is to draw a free body diagram. And so we know we've got force gravity down on the box and force applied by the rope up on the box. And because it's going at a constant speed, we know that those two forces are going to be balanced. So if we try to think about what forces are doing positive work, what forces are doing negative work, and what forces are internal to the system, well, like I said, I tried to set my system this time so that all of our energy was going to be transformed or contained within the system, like there was going to be no outside work or forces done on the system. So in this case, both of these forces are internal to the system. Force applied being the rope and force gravity being the box and the earth together. So let's see, our LOL diagram would look like this. Initially, I'm going to say that that rope is transforming some chemical energy, whether that's from a motor with gas or a person pulling the rope, something like that. There's chemical energy that that rope is transforming into gravitational potential energy, because in the end, the box is being lifted up to 10 meters. Now we can jump into our energy initial plus work equals energy final equation. And we know that initially we've got chemical energy, and there's no work being done on the system, and in the end there's gravitational potential energy. So in the end we've got chemical energy is going to equal mgh. And ultimately this is our transfer of energy. Energy is transforming from chemical energy to UG. That is our delta E. That is our transformation of energy. So if we can find our mgh, then we found our delta E. Our change in energy, our transformation of energy, is 5,880 joules. We can jump into our power equation, which is change in energy over time. So 5,880 joules over 5 seconds gives us 1,176 watts. So every second, this means it's a rate. Remember, it's a rate that energy is being transferred. So every second, 1,176 joules are being transformed, I should say, from chemical energy into UG. So I thought we could take a quick look at this if we were to set our system up so that there would be energy transferred instead of transformed. And so if we did that, we would make our system the box and the earth. And our free body diagram would look exactly the same. The motion would look exactly the same. The only difference is force gravity is contained in our system because the box and the earth are in our system. But this time, force applied is not in our system. It's doing positive work. So in which case our O is going to look like that, where we've got our energy being transferred into the system through the force applied by the rope, and that energy is then ending up as UG. Again, we can jump into our energy initial plus work equals energy final equation. This time our energy initial is 0. The work done by force applied is transferring energy into our system and into UG. So we can say work done by force applied equals mgh. And that is the transfer, the change in energy, I should say. The change in energy in the system is going to represent that. That is the transfer of energy. All this energy is being transferred into UG, so that's going to be our delta E right there. So if we can find the mgh again, then we have found our change in energy. Again, it's 5,880 joules. Plug that into our power equation. 5,880 joules over 5 seconds, again, gives us 1,176 watts. So there you go. 2 ways to approach the same problem, and it's both applying power both ways. One way was just looking at how energy can be transformed and how that transferred energy represents our change in energy. And the other example we looked at was how energy can be transferred and how that transferred energy is our change in energy. Ultimately, though, it's 2 ways of doing the same thing. Hope that was helpful, and I will talk to you later.